Today, guys, we're going to be talking about multiplying real numbers. So, when you're multiplying real numbers, it's all about how you multiply really doesn't change. It's just basically figuring out whether your answer is going to be positive or negative. Now, if the signs of the numbers that you're multiplying together or your factors, if the signs are the same, then your answer is going to be positive. But if the signs on your factors are different, your answer's gonna be negative. So signs the same, answer's positive. Signs different, your answer is gonna be negative. So in these first two examples, if you have a -6 times a -3, the signs are the same, so my answer is going to be positive, and it's just 6 times 3, which is 18. In example 2, -5 times, or excuse me, -4 times 5, signs are different, so the answer is going to be negative, and in this case it's going to be a -20. So what you get when you multiply is still the same. It's just a case of figuring out the sign. Okay. Now, little hint that can help you out, guys, when you're doing problems, because not all problems are going to be as simple as just two numbers being multiplied together. If you have multiple factors, if you have an, oops, forgot to change that. Sorry about that, guys. If you have an even number of negative signs, the answer will be positive. So if you have 6 negative signs or 2 or 4 negative signs, the answer will be positive. And if you have an odd number of negative signs, your answer will be negative. So if you have, say, 5 negative signs, your answer will be negative. Now, the thing that you're going to have to be really careful with is when you're working with negatives and exponents, because the position of parentheses, whether where the negative sign is within parentheses or not, and the position of the exponent is really important. So you got to pay close attention to it. When working with a real number raised to an even exponent, and there's a negative side involved, you need to pay close attention to the position of the negative sign. For example, this is when we're looking at this notation. This first problem really almost could look at it as taking the opposite of 3 to the 4th. You could almost look at it as even a -1 times 3 to the 4th, because you notice there's no parenthesis around that to make it a -3. All right, so you gotta look at it as the opposite. Whereas over here, if you notice on the right hand side, we have, it's like -3 to the 4th. Okay, because the negative sign is inside the parentheses. So this is like -3 times itself 4 times. All right. So this one would be like -1 times 81. 3 to the 4th is 81. So this is going to be a -81. Whereas here, we got 4 negative signs. This is going to be a positive. Positive 81. Okay, so you're going to have to pay really close attention to that. This is really like, the first one is really like the opposite of 3 to the 4th. This second one is -3 to the 4th. So they're very different. So you got to be careful with that. All right, let's go through some more examples. In this first example, if you see I have 3 factors, but I have an even number of negative signs. So before I even start, I know my answer is going to be positive. 6 times 4 is 24. Times the 2 gives me 48. Okay, and I saw I had an even number of negative signs, so I didn't really even need to worry about that it was a -6 times a -4. Okay. In the second example, I have 3 negative signs, so right off I know my answer is going to be negative. And you could even do this kind of in your head if you want to work it out. I tend to go, okay, 5 times 5, 25, times 3, that's going to be 75, and I know it's going to be a -75 because I have an odd number of negative signs. I have 3 negative signs. If you still wanted to just go from left to right here, you could, and just follow your rules. That's great, but to me it speeds it up when you can remember that hint of an even number of negative signs is positive, an odd number of negative signs is negative. In example 3, Okay. We have negative 4 times the opposite of x to the third power. Well, you can almost look at it as we have the opposite of x to the third power. That's a kind of like a negative raised to an odd power. It's going to be stay negative, and then times a negative 4 is going to make it positive. So we're going to have 4x to the third power. Here, in example number 4, if you notice, you have n to the fourth power, but the negative sign is outside the parentheses. So it's like you would take, if you actually plugged in a number for n, you would do that n to the fourth power first, and then take the opposite of it. So we got to leave that opposite sign there, and it's going to be n to the fourth power. Now, example 5, remember there's no parentheses around that negative sign, so really we got to look at that as the opposite of 2 to the fourth power. Another way you can think of it in your brain, again, is like a negative 1 times 2 to the fourth power. So you do the 2 to the fourth power first, which would be 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's like a negative 1 times 16, which is going to be a negative 16. All right, and that's one that often trips people up, so be really careful with that. All right, I want you guys to flip over your notes and try the practice problems on the back. Pause your notes. So try the problems yourself first, and then start back up the notes, and we'll go over the answers. Okay, ready? And pause. Okay, guys, hopefully you tried all these yourself, and now you're just checking answers. So let's go over the answers for these. Number 1, we've got 9 times a negative 3. Signs are different, so your answer is going to be a negative 27. All right. And number 2, and realize multiplication is commutative, so we could really do this in any order we want. We have an even number of negative signs, so I know it's going to be positive. I know half of 8 is 4. 4 times 6 would give me 24. Oops. And it's going to be positive because I have an even number of negative signs. Okay. Now in number 3, we have negative 3 because the parentheses include that negative sign, so that makes that a negative 3 to the third power. Now since it's raised to a third power, it's an odd number of negative signs, so my answer is going to be negative. And then 3 times 3 is 9, times 3 is 27. So it's going to be a negative 27. Okay. Number 4, I look right off, I know my answer is going to be positive because I have 4 negative signs, so it's an even number of negative signs. Half of 2 would, looking at the first 2, half of 2 would be 1. 1 times anything is the same number back, so we're really looking at just 3 times 5, which is going to be a positive 15. Okay. Number 5, we have the opposite of n times the opposite of n. Really, we have 2 negative signs, so it's going to end up being positive. So this would be like n times n, or n squared. Number 6, again, looks like we have 4 negative signs, so it's an even number of negative signs. So my answer is going to end up being positive. So this is going to be 4, and it's going to be x to the third power, because we have 3 x's multiplied by themselves. So 4x to the third power. Okay. All right, let me move this up a little bit. Okay. Here on number 7, we have the opposite of b cubed. Okay, so it's going to stay, it's b cubed, and it's going to stay negative. Now here, this is the opposite of y to the fourth power, but you notice that negative's inside the parentheses. So it's going to be like 4 negative signs, so it's going to be a positive y to the fourth. That's going to be your answer. You could think of it as opposite of y times itself 4 times. All right, so that makes it 4 negative signs, so that's why it ends up being positive. Number 9, we have negative 11 squared. All right, so it would be negative 11 times negative 11, which would be a positive 121. It's raised to an even power, so it's going to be positive. Number 10, we're raised to an even power, but realize we don't have a parenthesis around that negative sign, so it's like a negative 1 times 4 to the fourth power. All right, so this is going to be like negative 1 times 4 to the fourth power, which you have 4 4s, right? You can think of it as 16 times 16, which is 256. And so it's your final answer is going to be a negative 256. All right. Now, this next one says, next couple say, evaluate the expression when x equals -7. So realize you're going to have 2 times. Now we got to take the opposite of a -7 times the opposite of a -7. So what we really have here is 2 times 7 times 7, right? Because the opposite of a -7 would be a +7. So we're like looking at a couple ways, different ways we could do it. I look at it as 2 times 49. Some of you might be looking at it as 2 times 7 is 14 and then times the 7. So 18 carry the 1, we're looking at 98. All right, let's look at number 12. Okay, we got -5 times x in parentheses times a -2/7. Well, I could look at this right off and say, well, I've got an even number of negative signs, my answer is going to be positive. And remember, multiplication is commutative, so I could almost switch this around and think of it as like a -5 times a -2/7 times x. And remember, -5 the whole as a whole number is the same as in fraction form as -5/1. So we're really looking at basically 10/7 times x, which throughout the year we're going to be doing some stuff where we sometimes leave it in improper form like this, or we could change this in this case to 1 3/7 x. And that will be our answer. All right, guys. Hopefully this helped a lot in going over and refreshing your brains and clarifying some things, and you can get started on the multiplying real numbers homework.